So today we are learning about implicit differentiation. What we have been doing before, if we have an expression like this one, y is equals to 2x plus 1. This one is called a what? Explicit function. Why? Because you can be able to see that y is on one side and all the other function is on this other side. So that's what we call it what? An explicit, whereby you can be able to make y the subject of the formula. But again, there are some functions that you cannot be able to come and make y the subject of the formula. This one, I'll start from the basics. This one, dy dx here, will be given by what? The power is number 1, the power will come down, that is 2. 1 times 2, that is still 2. Then reduce the power by 1, 0. And then you differentiate a constant, you still get 0. So the answer will only be number 2. That's the dy dx. Explicit is very easy. When you differentiate y, we get dy dx. And then this other side, we use power rule to come and differentiate. Now, we have a function like this one. Let's say like that one. Now this function, if you check it clearly, even if you try to make y the subject of the formula through factorization, through bringing like terms together, it will not be able to work. So this function, we call it what? Implicit differentiation. Sorry, implicit function. It's called an explicit, whereby you cannot be able to make y the subject of the formula. We call it an implicit function, and it is still possible to come and differentiate this one the normal way. So what are the rules of differentiating using implicit? So the rules are easy. There are 3 rules. You have to remember them. Rule number 1. So differentiate x. We differentiate x normally are using power rule. So we differentiate x using power rule. So for example, we have been given x to power 3. When you differentiate x to power 3, you'll be able to get what? The power will come down, then you reduce the power by 1. Only that. If we have x raised to power 2, again the power will come down, you reduce the power by 1. So the normal way we have been differentiating the x, there's nothing that will change there. So that is the first one. So the first rule basically you have covered. It is easy. Now the second rule, when you differentiate y, what do we get? So we differentiate y still using power rule, but multiply with, after we differentiate using power rule, we multiply with dy dx. Multiply by dy dx. So after you have differentiated y, because we want dy dx. So it's only the y that when you differentiate using power rule, and then we do what? We multiply by dy dx. For example, if you have been given y, look at this previous example that I have done. This one. Check this one out. I had y is equals to 2x plus 1, and I claimed that when you differentiate on the on the left hand side, the y, we got what? We got dy dx. And you can be able to see we have been doing it basically without knowing. So when you differentiate this side y, we are getting dy dx. Now the x, when you differentiate the x, we just differentiate the normal way. So that is the only difference. Differentiate y, you multiply by dy dx. And I'll be able to demonstrate how you are getting that one. So let's go to the y and differentiate some of the functions and see what you are getting. So if I differentiate y using power rule, any number can be given as power 1. So the power will come down when you differentiate. Reduce the power by 1, that is 1 minus 1. then you multiply by dx. So what I'm saying, you'll have to introduce this function. Use power rule, then you do what? You multiply by a factor of dy dx. So this one, any number raised to power 0, that is 1. So you'll end up still with dy dx. And that's how we get it. When you differentiate y at the back of your mind, I just want you to remember that when you differentiate y, you will get dy dx. Simple as that. Can we try y squared? Can someone try y squared? I want to see y squared when you differentiate. So you still use power rule, and then there's something you must be able to add. So using power rule, the power will come down. Our power is 2. So 2, and then 2 minus 1. But we have said when you differentiate y, when we see a y, we shall just be able to multiply with dy dx. After you differentiate, you multiply the factor of dy dx. So here the answer, what Helen you missed was the what? Was the dy dx. What you missed, this one here. That's what we have said. This one you must always remember to introduce it. So the power will come down, that is power 2 will come down, reduce the power by 1, and then you multiply by dy dx. So final one, try this one, y to power 3. Y to power 3. Y to power 3. Try that one. Give me the answer for that one. Y to power 3. So this one, we are getting the power will come down. The power will come down, that is 3. Reduce the power by 1 squared, but we multiply with the function of dy dx. Very important. Simple as that. Simple as that. Let's go to number, that is number what? That is the number 3 now. Number 3. So when you have a product of x and y, you have a product of x and y, we use product rule. We use product rule. When you have a product of x and y, we use product rule. So product rule means we shall differentiate one, leave the other one as a constant, then we do the vice versa. That's what we covered in the last class. Product rule means to differentiate one, and I'll be able to demonstrate. Let's say you have xy. When you differentiate this one here, the x. So product rule means you can choose whatever that you want to start with. So for me, let me start with x to be my constant, and then I differentiate the y now. When you differentiate y, we said what? Y, don't use power rule. When you differentiate y, we said you always get dy dx. Even if you use power rule, it will still have dy dx plus. Now, because x was my constant, let now y be my constant now. Now I differentiate now the what? The x. The x, when you differentiate normally, you'll get number 1. So here the answer will be what? X dy dx plus what? Y. So when you're using product rule, if you go back to the formula for product rule was given by this one. If you have been given y is equals to uv dy dx, you don't have to do with the formula. U dv dx plus v du dx. What are you doing here? We are taking one. Look here, we have u and v. So we have taken v. We have differentiated v. Then we have u has remained as our constant. Then we have done the vice versa now. V has become our constant. Then we have differentiated the u. So that is what product rule means. You differentiate one, leave the other one as a constant. Then you do the vice versa. Very important. You do the vice versa of differentiating. Differentiate one, leave the other one as a constant, plus the one that was you are differentiating now becomes your constant, and then you differentiate the other function. So this one, what we have done, x was my constant, so this one we differentiated the x here. This one the y, sorry, we got dy dx. Then the other way around, our y became our constant, so we differentiated the x to get number 1. So you can be able to start with any function because it is addition. It doesn't matter. You can start with any. Let me do another one here. If we have a x squared and y squared, so this one is a product. This one is a product of two functions, x squared and y squared. So you can't just differentiate using power rule. So avoid this. I'll see some people doing this. So avoid this. At the power will come down, you get 2x squared, 2x raised to power 1. then 2y raised to power 1, and when you multiply by dy dx. Avoid this one. This one will be wrong, totally wrong. When you have a product, we said we always use product rule. So avoid that. So this one now, we have x squared and y squared. So when we want to differentiate, we shall leave one as a constant, then we differentiate the other one, and then we do the vice versa. So in the first one, let me leave x squared to be my constant. I'm using product rule. So I differentiate y. Oh, sorry, not y squared. When you differentiate y squared, we have said the power will come down. That is 2 raised to power 1. But because I'm differentiating the y, I multiply by dy dx. And I'm done with that one. I'll come to simplify later. So our x squared has remained as a constant, but we have said when you differentiate y using power rule, you must multiply with a function of dy dx. Now I'll do the vice versa. So here x was a constant, x squared was a constant. So now the other way around is y squared will be a constant. Now I differentiate now my what? My x squared now. When I differentiate now my x squared, the power will come down, then you reduce the power by 1. For x, we don't multiply with anything. We don't multiply with anything. So the final answer that we shall be able to get here is what? 2x squared y dy dx plus 2xy squared, or 2yx, or 2y squared x. It doesn't matter the order, but I always love to do with the a b c d. We do with the x and then we go to the y. So very important, product rule will work. Product rule will work. Let me give you one to try here. X and y to power 3. Try that one there, differentiate that one. So we have said that one is a product of two functions, and we'll need to use what? Product rule. Because we never differentiated the x. So we have said we are using power rule. So the first function, we shall make it as a constant. Then we differentiate y to power 3. So the power rule will still work. The power will come down 3y squared. But we have said when you differentiate y, people who are coming in, you will be able to multiply with a function of dy dx always. So when you differentiate y, always multiply with a function of dy dx higher. Now our x was a constant. Now y to power 3 will become my constant now. Then I differentiate the x. When you differentiate x upper, x is raised to power 1. The power will come down, reduce the power by 1. So you'll always end up with number 1. When you differentiate x, we'll always get to number 1. So here the final answer will be 3xy squared dy dx, and then plus y to power 3. So Helen and Kibara, I don't know how you are getting the x here. You never differentiated the x. Very important. So people are coming in, when you differentiate in terms of y, multiply with dy dx always. Dy dx. So a final one. The final one. Let me add some spice. 2x squared y. That one there, we differentiate that one. See what we are getting. 2x squared y. So the only hint I'm giving you here, remove the 2 outside, then differentiate what? You differentiate x squared and y first. So remove the x squared, so you differentiate these two. So that's the hint I'm giving you. You remove the 2 outside, and then you differentiate x squared and y. Then you multiply with a factor of 2 later. So that is the hint I'm giving you. So you can try that one. We are using again product rule. Differentiate one, leave the other one as a constant. So what we need to do when we are differentiating, we have said the 2 will remain outside, no problem. So x squared will be my constant. Now, people who are coming in late, we have said when you differentiate y always, you'll always get dy dx. Even if you use power rule, y raised to power 1, the power will come down. So that is 1. Reduce the power by 1. and then you multiply with a function of dy dx. When you differentiate y, you must multiply by dy dx. This one, the first thing here will always be number one. So when you differentiate y, you don't have to do the power rule. You'll always end up with dy dx. Now differentiated the y. Now I do the vice versa now. Y will become my constant. Now I differentiate x squared. So x squared, the power rule will still work. You'll end up with only 2x. And you are done with that one. You'll end up with 2x. So you can be able to see my constant is outside. And then what I've done, I've just differentiated x squared and y using product rule. X squared was my constant, differentiate y, you get dy dx. Then you do the vice versa. Y becomes my constant, you differentiate x squared, you get 2x. So it's a matter of now multiplying. So the final answer will be 2x squared dy dx plus 4xy. The final answer, 4xy. Because I have a factor of 2 outside here, it will be able to come and multiply. Now, let's go now to the final thing. Now, after we have differentiated the implicitly, this one is called differentiating implicitly. We are at now number 4, the final step. We make dy dx, the subject of the formula. Now I'll be able to show you how we do that. We just make dy dx the subject of the formula, and then we are done. So we are done with differentiating. Let's do an example now. If you have understood what we have done there, this one will be very, very easy. I'll start with a very simple example. Number one, x squared plus y squared plus x to the power 3 plus y is equals to 4. So this one is called an implicit function. Why? Because even if you try to make y the subject of the formula, it is impossible. It is impossible to make y the subject of the formula, and I guarantee you it is impossible. So we shall differentiate what? Implicitly. It's called implicit differentiation. We shall differentiate implicitly. So how do we do this one? So in the previous section, we covered the rules, but we shall still be able to cover the rules. So rule number one was saying when you differentiate x, just use power rule. Just use power rule. So when you're differentiating x squared, our answer will be what? 2x. And then plus. To differentiate x squared, you get 2x. Very simple. Let's go to the y squared. When you differentiate y squared, we shall use power rule. But when you differentiate, you multiply with the factor of dy dx. Very important. So the power will come down. So you'll get 2y. But because I'm differentiating y, I multiply by dy dx. So I'm done with that one. I go to x to the power 3. X to the power 3, you just differentiate how you know it. The power will come down. Then you reduce the power by 1. So I'll end up with 3x squared. Then we have said, even if I use power rule, the power will come down. Reduce the power by 1, we'll end up with y raised to power 0. And we have said that at the back of your mind, when you're differentiating y, you'll always end up with dy dx. Simple as that. Now, when you differentiate a constant, what do you get? You get 0. When you differentiate a constant, you get 0. Now, our main task is to bring like terms together. We bring like terms together by making y the subject of the formula. Now, what I'll be able to do, these functions that have dy dx, they remain on the what? They remain on the right hand side, on the left hand side. Sorry, whatever that does not have dy dx, I'll take it to the what? To the right hand side. So I remain here with 2y dy dx. There's another function that has dy dx, which is this one. Now, 2x when it crosses over shall become negative 2x. 3x squared shall become negative 3x squared. So that's the first thing you do. That's the first thing you do. You remain on the left hand side with the only functions of dy dx. Now from there, we use something that I love. It's called factorization. Because what we are doing, we are finding dy dx. So I'll factorize dy dx. When you factorize dy dx here, you remain with what? 2y. When you factorize here dy dx, you remain with number 1. So negative 2x minus 3x squared. Now, how can I be able to get the value of dy dx? I divide both sides by this function. So dy dx will always be given by negative 2x minus 3x squared all over what? 2y plus 1. This one will come this side so that I remain with dy dx. So that is the reason of factorization. That is the reason of factorization. That's why we are factorizing this one. Number 2. I give you a chance before I do it. This one is not an implicit function, but for the sake of revision, let's do this one. A simple one. Want to see if you can be able to do that one. X squared plus y squared. You differentiate that one what? Implicitly. Try that one. So the only thing that I'm introducing here is not Terence. Okay, I think he has seen his mistake. So we do this one. So differentiate x squared the normal way, you'll get 2x, no problem. The power will come down, reduce the power by 1. Differentiate y, the power will come down, reduce the power by 1, but you multiply with a function of dy dx. Differentiate 10, which is a constant, you get 0. Here there's no matter of factorization because there's only dy dx. So I'll take this other side. So 2y dy dx will be given by negative 2x. This one means that dy dx will be given by negative 2x all over 2y. And then I cancel the 2 to negative x all over y. So if you're unable to simplify, please just simplify. Cancel the 2. Why have the 2? So negative x plus. But at least now you are okay. I think you are getting what we are doing. Number 3. X minus y plus xy is equals to 5. We do this one. So again, the same procedure. The x using power rule. This one is power 1. So the power will come down, you reduce the power by 1. So when you differentiate x, will end up with just number 1 minus. When you differentiate y again, y we have said at the back of your mind, when you differentiate y, the power will come down, but will end up with the dy dx because you must multiply the function of dy dx. Now this other function, if you read it correctly, it is x times y. So x times y, we remember that we must use product rule. Please remember that we must use product rule. We have x and y. So we must use product rule here. So I'll put here my brackets here. And then when you differentiate a constant, you'll get 0. So I want us to use product rule quickly. So x will become my constant. Then I differentiate now the y. When you differentiate the y, we have said you'll always end up with dy dx. No problem. Plus, I do the vice versa now. X was my constant. Now y becomes my constant now. Now I differentiate now the x now. When you differentiate x, we get number 1. So that one is very, very important. If you forget about product rule, you are done. X becomes my constant, you differentiate y, you get dy dx. Then you do the vice versa. Y becomes my constant, then you differentiate x. Let me open up the bracket. Now you open up the bracket. A positive times a positive is still a positive. A positive times a positive is still a positive is equals to 0. Now I bring like terms together, the dy dx. So I'll end up with negative dy dx plus x dy dx. Then I have a 1 there. The 1 will come this other side. So it will become negative 1. And then I have the y, it will become negative y. Then I'll have to do some factorization here. Dy so dy all over x. Factorize here will only remain with negative 1. And here will end up with only x is equals to negative 1 minus y. So here dy dx will be given by this one. So I divide both sides by this function negative 1 minus y all over negative 1 plus x. The most important thing is the first bit. If we have product rule, if you forget about it, this one is just a matter of just a manipulation factorization, which anyone can be able to do. The most important thing is here. The product rule, that is where most people forget. People read it very good, x times y or xy. This one here. If you forget about that one, the product rule, then you are done. This is the most important thing for me. Number four. Number four. Number four. I give you a simple one to try. You try that one. Very simple. Want to see if we have understood that one. So we are saying that when you have this one, we differentiated 4x squared to get 8x. Then we differentiated x squared times y squared using product rule. X squared became my constant, then you differentiate y squared, the power has come down, you reduce the power by 1. But because you are differentiating y, you always multiply with the function of dy dx. And then the other one, y squared became my constant, then you differentiate x squared, you get 2x. Differentiate a constant 6, you get 0. We open up the brackets, this is what we got. Then we brought like terms together. So the function that has dy dx, it remains on the left hand side. Then the other functions, all of them go to the right hand side. Then we made dy dx the side of the formula by just dividing. Number 5. The final example that I'm doing is this one now. X to the power 3 minus x squared y minus 2xy. Now this one is possible to make it. Let this one be squared like that. The final example that I'm doing is this one. X to the power 3 minus x squared y minus 2x squared. So we differentiate quickly. So x to the power 3, the normal way we differentiate will end up with 3. We'll end up with 3 x squared. But now this other one, I have a product of x and y, so I'll use product rule. So the same there is minus. So I will leave x squared to be my constant. Differentiate y, we said we always get dy all over dx. Then I do the vice versa plus. Now y will become my constant. Then you differentiate x squared, you get 2x. The negative, you leave it outside, please. Put the bracket and then you leave the negative outside. The other one again, I'll leave negative 2 outside. When you differentiate, sorry, I will leave x to be my constant. When you differentiate y squared, the power will come down. That is 2y. And then reduce the power by 1. You remain with we multiply the factor of dy dx. And then I'll do the vice versa. Y squared will remain as my constant. Then you differentiate x, you remain with number 1. And then on the right hand side, when you differentiate negative 2 is a constant, you get 0. So you can be able to see when you're using the product rule, please use the bracket. Please, 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 please use the brackets. If you don't use the brackets, you'll make a simple mistake. If you have a constant, just remove it outside. Then you shall be able to come and multiply later. Let me now open up the bracket now. A negative times a negative. Sorry, a negative times a positive will end up with negative x squared dy dx. We have another one, a negative times a positive is still a negative 2xy. That is the most important thing about brackets. You'll never make a mistake when you come to the sides. The other one is a negative times a positive. We have a 2 and a 2. We shall end up with negative 4xy dy dx. And then I have a negative times a positive is still a negative, negative 2y squared. And then this side is 0. So you can be able to see what I'm getting. Very important for me. Now after doing that, I bring these ones that have dy dx will remain on this side. So I'll have negative x squared dy all over dx minus 4x xy dy all over dx. Then I take 3x squared will become negative 3x squared on this side. I have positive, negative will become positive 2xy. I have another negative will become positive 2y squared. Now I do some factorization. I factorize the dy dx. Sorry, brackets negative x squared minus 4xy. It will be the same as what we have here, negative 3x squared plus 2xy plus 2y squared. Now I make this one the side of the formula, so dy all over dx will be given by negative 3x squared plus 2xy plus 2y squared all over negative x squared minus 4xy. So the most important thing for me was here, how I was able to put the brackets. The brackets for me are the most important thing here. The bracket, the sign, take it outside. That one and that one. If you miss on the brackets, then you are done. And then when you come to the multiplying, make sure when you're multiplying a negative times a negative is positive, a negative times positive is still negative. Very important for me. And then that's the final answer that you get. So most of the marks are here. The other one is just simplification. The first part of differentiation, that's where most of the marks are. The other one, if you make a small mistake, we can easily be able to the process, but most of the marks are on the differentiation. Most of the marks are on the differentiation. So I've given you an exercise. After this, the discussion forum, I've given you like how many questions? I think there are 4 questions in implicit differentiation. You differentiate them, and then I'll be able to comment your answers. Is it okay, class?